Hey, what's up, Logic fans? Welcome to another video. In these videos today, we're going to cover section 5.3 of the text, which is our third section on quantificational semantics. Here we're going to learn how to incorporate relations into our Tableaux techniques and the Tableaux way of presenting interpretations of quantificational sentences. Let's rock. Okay, so before we learn how to introduce Tableau for quantificational sentences involving relations, we should gather a little preliminary result first that will sort of range over our entire discussion today. So I've arranged this little exercise for you so that you can really understand this point. But think about the relation RXY. Okay, now notice, of course, this is not yet a sentence, right? It's a form. Okay, but it can be turned into a sentence. One way of turning RXY into a sentence is by supplying it with the X and the Y with individual constants, right? So this would turn it into a sentence, this would turn it into a sentence, this would turn it into a sentence, that would turn it into a sentence, okay? So we can take this form of a sentence and we can turn it into an actual sentence by supplying individual constants, okay, or objects that I'm calling here. Now, let's suppose you've only got one object, little a, one individual constant, little a, okay? My question for you is how many sentences can you form from this form given a single object, a? Okay, so pause now and take a second and see if you can answer that question. Okay, so hopefully you've had a chance to pause and think about it, but right, there's only one way you can take this form and turn it into a sentence given a single object, little a, and that would be like this, okay? This would be the only way you could form a sentence. So, it's not like there's a difference between this a and putting it here and, sort of switching their places. It's RAA. A bears R to A, okay? So this might say A loves A or A loves itself as an example, okay? So that's the basic idea, okay? RAA. Now, let's collect our result here, okay? So if you only have one object, little a, you can take this form and turn it into a sentence in only one way. Suppose you had two objects, little a and little b, okay? So suppose you had both of these, all right? How many different ways could you turn this form into a sentence giving those two objects? Pause now. Okay, well, hopefully you've had a second to think about it, and really do take the time to think this through, okay? But here's one, okay? And then here's another. All right, and then you've got the B cases where, B is in this position, so you got RBA, and then you got RBB. So there's four of them total, right? There's four different ways you could turn this form into a sentence given two objects. All right, here's the two cases where A is in the first position, and here's the two cases where B is in the first position, right? Okay, pretty straightforward. Now, let's keep it going. How many sentences can be formed if you had three objects, A, B, and C? Okay, pause now. All right, well, in this case, you're going to have to do it like this, right? You're going to have, again, this is the cases where A is in the first position, and it can bear it to itself. It can bear R to B, and it can bear R to C. Similarly, you're going to have the third case here, right? And then you've got all the cases where C is in the first position, right? So that would be like this, for example, and as you can see, there's 9, okay? Now, last one, and then we'll build up to our general result, okay? How many sentences can be formed if you had a fourth object, D, A, B, C, and D? Pause now. Okay, hopefully you're able to get it, right? But it's going to be RAD, then you're going to have RBD, and then you're going to have RCD, and then you're going to have all the cases where you've got D in the first position, right? So it's going to look like this. Okay, and of course there's 16 of those, right? So, it's a 4x4 grid, basically, is the idea. Okay, so you've got 16. All right, now what I want you to do is extrapolate a general formula. If you have n objects, how many possible sentences can be formed? So if you had a sub 1, a sub 2, a sub 3, a sub 4, dot, 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 all the way up to a sub n. How many, and those were all your individual constants, if you had n individual constants, okay? How many different sentences could you form given that? In other words, can you extrapolate a pattern? Okay, hopefully you've had a chance to think about this, right? But, the idea is hopefully you've noticed, right? You're forming a perfect square every time, and that's your big hint. So it's going to be n squared, okay? So notice that if you've only got one object, 1 squared yields 1, right? And so that gives you the answer there. But if you had 2 objects, right? If you had 2 objects, you would have 2 squared would yield 4. If you had 3 objects, you'd have 3 squared equals 9. If you had 4 objects, you have 4 squared is 16, and if you had 5 objects, it'd be 25 possibilities, right? So you're going to sort of need this general result for what we're going to do for the rest of the day, okay? So the total number of possible sentences you can form given n objects from a relation is n squared, okay? So just make sure you keep that in your back pocket. Okay, so noting the n squared idea, let's jump straight into an example that explains how to do relational Tableau. And I think you're going to find this actually pretty simple. So we're going to start just by looking at this particular example. So here's a sentence. Notice it's got relations in it. In fact, it's only got the one relational constant, r. Okay, but it's fundamentally a conjunction, right? So this is the main connective, and the left conjunct is a disjunction, and the right conjunct is just this guy right here. And we have to provide a Tableau interpretation, which makes it true. And we got to provide a Tableau interpretation, which makes it false. Okay, so I'm going to go through the true one with you, all right? And what you're going to do is basically you're going to set up, independently of any property constant Tableau, you're going to set up a second Tableau, which we're going to call relation Tableau. And since this is the true one, I've got it sort of color-coded here, okay? Now, notice, if you were to set up a relation Tableau, you might be looking at this saying, well, gee, I've got little a, little b, and little c. So that means I should actually have 9. I should have RAA, RAB, RAC, RBA, RBB, RBC, RCA, RCB, and RCA, right? Well, that's true, but since our sentence only involves these 3, we only really need to think about them. And so in our Tableau, that's all we're going to present. We're only going to present these 3 out of the 9 possible ones because those are the 3 that affect the truth value of this particular sentence. So you're not going to have to do it out every time, okay? So we're only doing 3 of the 9, which is kind of nice. Now, in order to make it true, okay, we're just going to use the same procedure we did before, right? It's a conjunction. I've got to make this true, so I'm going to put a plus here, and this indicates that C bears R to B. So if R is the loving relation, that indicates that C loves B, okay? And we also got to make the left conjunct true. Fortunately, it's a disjunction, so we only got to make one of those true. So leaving this blank, this is an interpretation that makes this sentence true, okay? And so and this Tableau is going to count as a relation Tableau, which makes that sentence true, okay? So given all of that, go ahead and see if you can provide a Tableau interpretation which makes this sentence false. Pause now. Okay, so hopefully you've had a chance to think about it, but actually it's pretty easy. Since what we're working with is a conjunction, we just have to make at least one of the conjuncts false. So the easiest thing to do here is to simply put the negative there, right? The minus there, and that indicates that it's not the case that C loves B, right? And since it's not the case that C loves B, this sentence has to be false, okay? So the basic idea is we're just adding a second Tableau in addition to our property constant one, a relation Tableau, which handles all of those cases, all right? And we don't have to present the Tableau for all 9 in this case. We just need this 3, okay, because those are the ones that affect the truth value of the sentence we're examining. All right, let's look at some more examples. Let's try an example that involves both a property constant and relations, so you can see it all together, okay? So I'll walk you through the first one where we're going to make this sentence true. Okay, in a case like this, what we're going to do is we're going to have 2 tableaux. Okay, so our interpretation is going to ultimately look like this. All right, so we're going to have a tableau for any and all of our property constants along with the objects in the domain fully presented and specified. Notice in this case we actually don't need the C case. Okay, so we need RAB and we need RBA. All right, so all we need for our relations is this case, right? And the big idea is just that we can quite simply, now that we have both of these on board, assign pluses and minuses in such a way that the sentence comes out, in this case, true is what we want. So what I did here was I did the really simple thing of just making the antecedent false, and then I could just leave everything blank. Right, because with a false antecedent, you're going to have a true conditional, and it doesn't matter how you fill in the rest. But there are other possible solutions. For example, if you had made the antecedent true, you would thereby be forced, in this case, since we're trying to make the whole sentence true, make the consequent true as well. And since it's a disjunction, you could do whatever you wanted there. So, for example, you could have done this and leave everything else blank. And this would be an interpretation with both of these tables together, the property constant table and the relation table together, which makes this sentence true. Okay, so noting that, and that you just present, both Tableau for the one interpretation, can you give me an interpretation of this sentence which makes it false? Pause now. Okay, hopefully you've had a chance to pause it, and we'll come back and do this together. So in order to make it false, right, I have to have a true antecedent and a false consequent. So I'm forced to go ahead and make the antecedent true. And since this is a disjunction, I need it to be false. Both disjuncts must be false. And this is, we're leaving this one blank, so you could do whatever you want with the object B with respect to the property F. But basically you have to have a plus here and a minus here and a minus here, and then either a plus or a minus there. Either way, this is going to provide you with an interpretation that makes that particular sentence false. So again, big picture idea, if you've got both property constants and relations in a sentence, what you want to do is present both a property constant tableau and a relation tableau. All right, let's keep practicing some examples. And in fact, since we're running a little low on time, I'm going to continue some more examples and aspects of relational Tableau on the next video. So look for 5.3b, and we'll see you there.